Experiment OC22B to show that there is carbon dioxide present in air. For this experiment, we have a conical flask containing a chemical called lime water, and lime water changes colour from clear to milky in the presence of carbon dioxide. What we will do is, we will suck on this pipe, or inhale on this pipe, which causes carbon dioxide and normal air to get sucked in through the other pipe. This will cause the lime water to change colour from clear to milky. After 10 minutes of inhaling through this pipe, which caused air to get drawn in through the other pipe, the lime water has changed colour from clear to milky. This indicates the presence of carbon dioxide in the air. That is the end of experiment OC22B. Experiment OC22C, to show that there is water vapour in the air. For this experiment, we take a clean, dry test tube and place some ice and ice water in the test tube. After a period of time, condensation appears on the outside of the test tube. We test that liquid by using cobalt chloride paper, which is blue when dry, pink when wet. When we take the paper off the test tube, it has clearly changed colour from blue to pink. The only chemical that causes it to change colour is water. This proves the presence of water vapour in the air. That is the end of experiment OC22C. Experiment OC24, to prepare a sample of oxygen gas by decomposing hydrogen peroxide using manganese dioxide as a catalyst. Safety glasses must be worn during this experiment. Here we are going to drop hydrogen peroxide, which is this clear liquid, onto the black powder, which is called manganese dioxide, which acts as a catalyst. That means it alters the rate of the reaction, but does not get used up itself. We are going to collect the gas by the downward displacement of water. We slowly allow the peroxide to fall onto the manganese dioxide, and we can see that the gas produced is coming across and it's being collected above the beehive shelf. We will collect 4 jars of the gas and do a series of tests on the gas. We have now collected 4 jars of oxygen gas, and we will perform a series of tests on those jars of gas. The first jar we will test to see if it is indeed oxygen. To do this test, we will insert a glowing splint. So we light a splint, blow it so that it's still glowing, and place it in a jar of oxygen. And as you can see, the glowing splint will relight when placed in a jar of oxygen. This proves that the gas is oxygen, as oxygen is the only gas that will relight a glowing splint. To the second jar of oxygen, we will add some universal indicator. This will tell us whether oxygen is an acidic gas, a basic gas, or a neutral gas. We add 4 to 5 drops of universal indicator, and we stopper and shake the jar. As you can see, the universal indicator remains green. This proves that oxygen is a neutral gas. To the third jar of oxygen, we will add some burning magnesium. Magnesium is a metal, and it burns with a bright white flame. We will now place the burning magnesium in a jar of oxygen, where it glows extremely brightly. This is because oxygen supports combustion. The magnesium is burning in oxygen, producing a compound called magnesium oxide. The compound formed is magnesium oxide. We will now test its pH. Again, we add a few drops of universal indicator. We stopper and shake the flask. And as you can see, the solution turns blue in colour, indicating that magnesium oxide is a base. The fourth test we will do is we will add some burning charcoal to a jar of oxygen gas. The charcoal is slow to ignite and it only burns with a dullish flame. So once it's lighting, we will plunge it into a jar of oxygen. We now place the burning charcoal in a jar of oxygen gas. And again, as you can see, it burns much better in oxygen than it did in air. We will now test the products of combustion. So to the gas jar, I'll add a small volume of lime water. We will stopper and shake the jar. After shaking the gas jar for a couple of minutes, it can be clearly seen that the lime water has changed colour from clear to milky. This indicates that one of the products of the combustion of charcoal is carbon dioxide. That is the end of experiment OC24. Experiment OC27, to prepare carbon dioxide gas and examine some of its properties. For this experiment, safety glasses must be worn at all times. The preparation of carbon dioxide is done by dropping dilute hydrochloric acid onto calcium carbonate, or marble chips as are commonly known. To collect the gas, we will do so by the upward displacement of air. So as the acid lands on the marble chips and reacts, the gas produced travels through the delivery tube, and as the gas is collected in the jar, the air is forced upwards. This is because carbon dioxide is more dense than air. We will collect 3 jars of the gas. So as you can see, the acid and the marble chips react, fizzing, producing carbon dioxide gas. The gas is being collected in each of these 3 jars by the upward displacement of air. We will now collect 3 jars of the gas. We've collected 2 jars of carbon dioxide. To the 3rd jar, I have added some universal indicator, and I will lower the delivery tube into the universal indicator. The colour change will be from green to red, indicating that carbon dioxide is an acidic gas.